Okay, today is monitoring of marine litter, and remember that it's key to intend in the monitoring as a point to make an assessment of what is happening on the seas. Okay, monitoring is a very important point to keep data, to obtain data, and to manage for then research, investigate, and to make a point on control to take measure on the future or in the present to advance in the measure that in the previous moments we're talking again. We have several people to talk with us. Okay, so we have Proyecto IMPLAMAC with Javier Hernández Borges. Between Land and Sea Microplastics in Madeira with Sonia. Madeira Beach Litter Monitoring Program with Ms. Nicola Pestana. OSPAR Monitoring, the Dutch Caribbean, very nice. Caroline. Combining citizen science with micro and plastic research in Iceland, Carlota. And technological solution toward enhancement of micro litter monitoring with Joa. Okay, so they are important, so go up.
Good morning, everyone. First of all, I would like to thank the organizing committee for their kind invitation to be here today. I'm going to talk about the IMPLAMAC project, impact of assessments of microplastics and emerging contaminants or pollutants in the Macaronesian regions. This is the acronym of the project and the logo, and it is an InterregMac project that has been financed with federal funds for the last 3 years. The project is led by the University of La Laguna here in Tenerife, but it also has several partners like the University of Las Palmas de Gran Canaria, the government of Las Azores, which has also asked the University of Las Azores for to participate in this project in a different way as collaborators. Also, the regional secretariat of the sea and fisheries of the government of Madeira, and Arditi, the agency of an agency of research and development, also from Madeira Island. And as a third country partner, we have the University of Cape Verde. IMPLAMAC is a research and development cooperation project on marine pollution in the Macaronesian region. And what we want to do is we want to create an observatory that generates quantitative and qualitative data on the amount of microplastics that arrive to the Macaronesian region. We want to know what microplastics arrive to the Canary Islands, when, how, and we want to know everything about this. And we also want to increase the public awareness of the importance of plastic pollution, and that is why we are currently also giving a high amount of talks and seminars and workshops on this issue. But before I start talking about the project, I would like to briefly highlight the importance of marine litter monitoring, which is also a topic of this table. And marine litter monitoring is important for several reasons. It is important to characterize marine litter, to identify their sources, as well as to determine distribution patterns. It's something very, very, very important nowadays. It is important to study, or marine litter monitoring studies allow us to know litter transport, as well as to determine accumulation zones. At the same time, they help us to identify certain problems or threats, as well as to increase public awareness of the conditions of the coastlines. And probably what is more important nowadays is that they allow us to see if the current policies that are being taken from a governmental point of view, if they are being really useful or not, if they are decreasing the amount of microplastics in the environment or not. IMPLAMAC project is divided in three main objectives. The first of them is this one: the improvement of microplastic sampling and analytical methodologies to study the distribution and to determine accumulation areas in beaches and sea surface. And that is why we have been monitoring 46 beaches in the last 2.5 years, which means that we have already collected developed 460 samplings and already analyzed 4,600 samples. And we have also developed 50 seawater samplings. This has allowed us to confirm previously hotspots of microplastics arrival, like the one in Playa Alhambra, in La Graciosa, Famara, in Lanzarote, as well as Playa Grande in Tenerife, and Porto Pim in Las Azores. But during this project, we have also found 2 new hotspots of microplastics arrival, one in Cape Verde, in Playa de Norte, and another one in El Hierro, in Arenas Blancas. And we are currently monitoring these 3 other possible hotspots in Puertito de Adeje, Almáciga, and Caletillas. I would like to briefly show you the results of the province of Santa Cruz de Tenerife, which is the ones that that my group is really in charge of, is currently in charge of this study, but the results are very similar to the ones that we are also finding in other archipelagos of the Macaronesian region. In general, we are finding important amounts of fragments, pellets, and foam. Pellets is microplastic, primary microplastics. And in most cases, we're talking about fragments and pellets. Only in small amounts, in certain specific cases like Almáciga, Nogales in La Palma, or Playa del Inglés in La Gomera, we are only finding foams. Concerning the distribution colors, which is important nowadays to try to understand the possible origin, we find that this pattern is very similar in all the province. In most cases, we are finding white, yellow, and blue fragments. The fact that they are white means that they have been extremely long time in the environment and that they are currently degrading. We are finding this pattern, exactly the same one, in all the Macaronesian region, except in the case of Madeira, in which one of our colleagues now will also present the results. But this means a similar pattern in all the Macaronesian region. Concerning the composition, most of them are polypropylene and polyethylene plastics, which are the 2 plastics most commonly produced worldwide, and they have also a low density, so they float, and that is why we find them normally in the beaches. In IMPLAMAC, we also had a second objective in which we have tried to study the effect of microplastics on trophic chains and ecosystems, and determining also possible effects on fish, and that is why we have analyzed nearly 800 individuals of these 6 different species. The ones that you have here, the ones, only one of them, the first 4 of them are common to all the Macaronesian region. The one in the middle, in the down part, is only found in Madeira, while the other one, the garupa, is only found in Cape Verde. And we have seen that approximately 53% of all these individuals, they do have contain microplastics in their stomachs, mainly microfibers, blue and black microfibers that come from our textiles, from our clothes. We still have to see exactly what is the composition or the current composition of those fibers. And concerning the last of the objectives, we are also particularly interested in determining contaminants that have been adsorbed onto microplastics. Microplastics act as sponges, and they retain on the surface contaminants like pharmaceuticals, personal care products, or hormones. And we have currently developed more than 9,600 analyses of 808 samples, in which we have determined all those pharmaceuticals that are indicated in the slide, and we have found that, for example, carbamazepine was found in 32% of the samples, octocrylene in 58%, or norgestrel in 67%. Finally, I would also like to show you very briefly that apart from this IMPLAMAC project, we are also developing, we are also studying the retrotrajectories of microplastics in the Macaronesian region in collaboration with the University of Las Palmas de Gran Canaria and the Spanish Institute of Oceanography, in which we are trying to model in the sea surface to see or to try to correlate this data from IMPLAMAC with this with the transport of microplastics in this region. We're trying to see or to justify why certain beaches are in fact hotspots of microplastics arrival. Thank you very much for your attention.
Okay, the next one is Sonia, with Between Lands and Sea.
Hello, I'm waiting for my slides. So, why they put the presentation? So, I'm Sonia. I'm from Marbury Research Institute, and I'm based in Madeira Island. So originally, I am not working originally from microplastic, but on zooplankton and from the Mediterranean Sea. So it was often when I was working in microscope that I see all these particles. And while it's kind of expected and sad to find all microplastic in the Mediterranean Sea, it was interesting to see how it's in the open ocean. And Oceanic Island, it's a perfect area, because basically we are like a station in the middle of the ocean. And even if the oceanic islands are a source of contaminant, but we also have access to the open ocean quite easy. It's interesting to see what came from the island, but also what came from other area through the currents. So in Madeira, we have two monitoring program working. One located for the beaches, which was presented by IMPLAMAC, we saw the presentation before, and one from HOTMIC project where we are focusing on the water, looking what are the microplastic in the water and see how they distribute horizontally, so from the coast to the open ocean, and also how deep we can find microplastics. So basically for the beach area, we are working as the previous presentation showed, we are looking for sandy beaches. The problem is that the weather doesn't make our work very easy, because after storms, we don't have any more sand, which means also that everything was in the beach go back to the water. Then for the water monitoring, we are working from coast, so like close to the potential contamination sources, and we go offshore to see what we can find from the island. We are using two different ways to look for them. So for the beach area, we are looking to up to 1 millimeters, but for the water, we have the ability to go to very small particles. We are going like to 200 micrometers, which are very tiny, and we are able to track them for now up to 300 meters. So we only know how far we can find particles, but also how deep we find them. So for Madeira, as previous with the Riviera said, there is no really big hotspot for microparticles contamination in beach around Madeira. However, when we compare, for example, Porto Santo with Madeira, there was a tiny little bit less particles in Porto Santo, which can be related to the cleaning process that happens in these beaches. And as I said, working on beach in Oceanic Island is a bit tricky, because after storms, we cannot work anymore there. So to have a monitoring program to see, for example, if you have more particles in winter or in summer, you need to be very careful about how often you go to this beach, so you can avoid going there and no sand, because there was a storm a couple of days before. Regarding the type of particles that we can find, it's basically we have two different patterns. For Porto Santo, they mainly find fragments, besides some exception in some beach, but in Madeira, most of the particles are foam. So this is what for the beach. Now goes to the water. For the water, we worked in 2 seasons, fall and summer, because we thought maybe when we have more rain can bring also more particles to the water, and also the ocean circulation is a little bit different. So it seems that we have more particles in fall than in summer, but I put seems because we are still processing the data. So potentially this would change, but I kind of doubt of. So now let's go to the small picture. If we are just focusing in the fall, so in autumn, basically between the different area, there is no big variation in microplastic. Even some area there is a little bit less. But still for an island is a little bit a lot if you not a lot, but if you compare, for example, for some microplastic in Mediterranean Sea, we have sometimes same value and even sometimes higher. Then when we go and break the picture in a smaller, so can we maybe the picture people maybe say, okay, you are close to the island, you can find more particles, and then you go far, you have less. And you go deeper, you have less. It doesn't happen, absolutely not. We have really different pattern, depends of area. Some area you have really most of the microparticle, we found them in 100 and 300 meters. So if you think that deep ocean are not impacted, they are impacted. So you will find microparticle not only in surface, but also in the deep ocean. So it's something that we have to really keep in mind, that not only surface, not only the beaches, but also the deep ocean ecosystem will be impacted by microparticle. Regarding the composition, no surprise, we have more fibers. It's because we sampled with super small nets. So of course we will have small things, and what we found small particles is mainly fibers. So everything that comes for the clothes. And this could be very problem because most often you don't see them, and you will find them after in the food web. And then we go break the picture with small pieces to see if, for example, you have more fiber, same thing in the coast or more in the open ocean. For now, it doesn't seem to have a clear pattern. So sometimes we have more fiber in the coast, sometimes we have more in the offshore station. And if we break the picture in the smaller again, same thing, it's a mess. There is no clear pattern. Some area we have really lot of particles in the close to the coast, sometimes it's far, and sometimes we have even more fibers or more fragments, depends on the area. So it seems that this correlated possibly with the ocean circulation, because of course everything when you go deep is not the same. So what we will do in the future? So this is, we are still monitoring the water and see what happens. And what will come in the future is to identify what type of particles we find in the water, the origin, we have more polymer, and if possible, potentially where they come from. And the most important thing after is their interaction with the fauna, because we have small particles that will be eaten by small animals, zooplankton, that will be eaten by fish, and so on. And we don't really know what are the future of these particles in the water, especially when they reach the deep ocean. So this is for me, on my side, so if you have questions, you are welcome.
Thank you. Thank you. Nicola, Madeira's Beach Litter Monitoring Program.
Hello, I am Nicola. I came from Madeira Island, the regional government of Madeira, and I will present you Madeira's Beach Litter Monitoring Program. I will talk about macro litter. Okay, Madeira archipelago, as you already know, is located in Northeast Atlantic and has four main group of islands: Madeira Island, Porto Santo Island, Desertas Islands, and Selvagens Island. As an oceanic island, we are facing an unprecedented risk because of the marine litter. So, with that in mind, the regional government of Madeira started in 2020 the Madeira's Beach Litter Monitoring Program that is coordinated by the Regional Directorate of Environment and Climate Change, with the cooperation of several entities like the Institute for Forestry and Nature Conservation, Waste and Water Management, and with municipalities, private entities, ONGs, NGOs, and citizens. This program has three main axes: awareness raising activities, scientific monitoring, and beach cleanups in remote accumulation sites. I will try to show you some of this work that we do in these three main axes. The awareness raising activities that we do are a part of a strategy that the regional government developed that is called MARAM strategy, that is pollution zero into Madeira Island Sea. And these activities are done by our technicians with the help of volunteers, with cooperation with municipalities, schools, nautical clubs, etc. And we do 3 campaigns per year, in March, in July, and in November. We do these cleanups. We do cleanups in 2020. We did in 19 beaches in Madeira Island and Porto Santo Island, and we do these cleanups mainly in bathing beaches. And the litter that we collect, all the litter that we find on these cleanups, and then the total weight is registered, and there are 3 specific items that we divide and count and weight separately. These are cigarette butts, plastic bottles, and also masks, because we want to know the effect of these items in the long term. We want to do this work. So the litter that we found here in these beaches are mainly litter associated with recreational use. The other part of this program is scientific monitoring. Scientific monitoring, we follow the guidelines of the OSPAR Commission. Like the beaches must have 100 meters long. They have to be completely exposed to the sea with no edifications and with no regular, and preferably not regular cleaning operations. We do this monitoring in 4 campaigns per year in spring, summer, autumn, and in winter. We collect all the items that we find in these 100 meters, and then we categorize it based in the OSPAR list. That is a list that has more or less 150 items, and that are divided into 13 main groups of material, like plastics, metal, glass, rubber, etc. This work that we do has started in 2020 with only 5 beaches, and now in 2023 we have 11 beaches, 8 in Madeira Island, 2 in Porto Santo Island, and 1 in Desertas Island. This work is done by a trained monitoring team, not depending on volunteers. And for us this is important because we can have solid data that contributes for the Marine Strategy Frame Directive report. And our data is also integrated, since 2022, is also integrated in OSPAR database, even though we are not part of OSPAR. The data that we collect in this scientific monitoring is also used is also part for some international projects, like Interreg Atlantic project Clean Atlantic, and also for Interreg MAC project Ocean Lit. Okay, the last part of this work this program is the beach cleanup in remote accumulation sites. In previous studies done in the scope of the Clean Atlantic project by the RDT team, that is, RDT is the regional agency for investigation and innovation, technology innovation. We saw they have managed to see that there are 3 main accumulation sites in Madeira that are represented in the map in the red color. So with that information, we started to do some cleanups in two areas in Madeira, as you can see in the map as in green. These sites are mostly inaccessible sites and remote sites, and we can go there only by boat, and of course depending on sea conditions. These are areas where we go for 1-2 hours and collect a lot of litter, as you can see in the photos. Even though we have tried we have managed to do some cleanups, and from 2020 to 2022, also in the scope of the Clean Atlantic project, an Interreg Atlantic area project, we have removed more than 4 tons of litter in these 2 accumulation sites. What we do in these sites, we collect all the litter that we can, and then we characterize it, not in the OSPAR list, but we try to, because there is it's a lot of litter, but we characterize it into some items that we know that is different from the litter that we find in the scientific monitoring beaches and awareness raising beaches. I am talking about I am talking about litter that we know that it is not from Madeira Island, like fishing boxes from Royal Greenland, buoys from Galiza, bait boxes from Maine, fishing crab traps and lobster traps from Canada and also from Maine. So these items we collect and then we count them and separately. But we are trying to do a work that we think that is very important. Is we try to identify possible activity sources and also geographic locations. And we know, as you can see, we even got a transport box from a North Korean company, Samlip. It's a North Korean company. So we collect a lot of garbage litter that we know that it's not definitely from Madeira. So with these 3 main axes of the program, we cover all Madeira Island and a great part of Porto Santo Island, and we are in the field most of the year. So I think we have the most complete, I think we can say we have the most complete and detailed beach litter monitoring program in Portugal. So what do we want to do next? We want to continue the awareness raising activities in the beaches that we do, and also adding some more beaches. We will continue the scientific monitoring, and we are increasing to. We're hoping to increase the number of beaches, beach cleanups in accumulation sites. So for that we have applied for a new project. In the line of the Clean Atlantic project, and if we are trying to increase in 2 more islands, 2 more beaches, one in Selvagens Island and one of north coast of Porto Santo Island. We think that now we are willing to develop and to know more about the methods to determine and monitor transboundary litter, and we will try to develop a matrix score for determining sources of litter in remote accumulation sites. So this is our main goal, is to develop this work with the remote accumulation sites. That is all. Thank you for your attention.
Me encanta lo puntuales que está.
Muy bien de tiempo, sí. No te apagan el micro.
Sorry, because the micro is opening. Okay, thank you. Caroline?
Great. It's an honor to be here today to speak to you about using OSPAR monitoring in the Dutch Caribbean as a roadmap for regional harmonization. So my name is Carolyn Caparuso. I'm the coordinator from Clean Coast Bonaire, which is a WWF Netherlands project. And I have to say that that photo is just gorgeous. Where did they find a beach that doesn't have any litter on it? This is an inspiration for us all. But unfortunately, where I live, some of the coastline looks like the photo you see here. And I think that the slogan of this conference, Islands, we are the standard bearers for clean oceans, because on our islands, we're closer to the coastline, our marine litter is more visible. Because we're dependent on our blue economies, we're much more vulnerable, and therefore we require more action. And that is how I started my journey in marine litter, looking at the beaches. You can't live somewhere and see that and not go and clean your beach. And then we realized that in order to work on solutions, we needed to collect data along with the litter. So if you're not familiar with the island of Bonaire, we are in the southern Caribbean. We're very close to the coastline of Venezuela. Our population is about 22,000 people, and we're only 38.6 kilometers long. We're part of the Kingdom of the Netherlands, and because tourism is basically the main part of our economy, I would rightfully be in large trouble with our tourism office if I didn't show you a few pictures of some pretty clean beaches. So we do have that as well. And our marine park is absolutely world famous for scuba diving. So what we know about marine pollution in the Caribbean is in fact very little. A recent report from the World Bank from 2019 tells us that we know that we have a very high concentration of litter in our region, and based on our population and estimated consumption, it is quite disproportionate. So we know that much of our litter is in fact coming from outside of our region. However, we really have insufficient quality assured data in place because we don't have the necessary systems there to collect the data. So the number one recommendation from this report is that we need to improve our analytics and our knowledge base by using common monitoring approaches. Essentially, we really need to harmonize in our region. And there has been quite a bit of progress, even between working between two regions on either side of the Atlantic. So a little bit of the politics of the region, we have the Cartagena Convention, and that protects a legal agreement to protect the marine environment of the wider Caribbean region, specifically through the LBS protocol, the Land-Based Sources Protocol. And then on the other side of the Atlantic, we've been hearing a lot about the OSPAR Convention that protects the Northeast Atlantic. So between the two regions, there's been a memorandum of understanding where marine litter was identified as an initial area for cooperation, including programmatic and technical support. In addition, within some of the islands in our region, we have some common contracting parties, including the Netherlands and Bonaire, where I live, as well as France and the UK. So OSPAR monitoring started in Bonaire in 2018, where one of my colleagues who conducted monitoring in the Netherlands came over and said, wow, wouldn't it be interesting to try it in the Caribbean Netherlands? And so we selected 3 different sites. They're surveyed as per OSPAR monitoring protocol 4 times per year. And we really strive towards a high level of stakeholder engagement by utilizing citizen scientists who are supervised, also collaborating with visiting researchers, and reporting our data to the government. And so far, we've collected almost 175,000 pieces of marine litter. Of course, taking something from the coasts of Europe and bringing it to the Caribbean, we had to make some modifications. The first one that was extremely apparent is we needed to cut our monitoring area in half because, it's much warmer temperature. Being out there on a beach collecting in the hot sun takes a while. And you heard from Lex's presentation earlier that within the OSPAR region, you find on average 200 to 300 pieces of marine litter. And I'm going to shock you with what we're actually collecting in a second. But we also started collecting information about regional items because taking the OSPAR data collection list, we kept write-ins. And so we started adding more commonly found items. And then in 2021, because we're working towards harmonization, we decided to superimpose the joint list of litter items from the EU on top of the OSPAR list. And that, in fact, gave us a few code numbers to put on some of, on some of our write-ins, because we wanted to have greater global applicability in the data that we were collecting, as well as having unambiguous identification of these new items. Now for my data. Quick visualizations of what we're finding. This is only showing 2019 to 2022. I took out all of 2018 because that was all for clearance, because OSPAR requires clearance as well as for training data. But starting with Boko Onima up in the northeast, on average we collect 2,500 pieces of marine litter per survey in a 50-meter area. Blue is plastic, and our most common item, making up 58% of the total, are small pieces of polystyrene. Then moving to the south to Piedra Pretu, averaging 3,000 items per survey, most common small pieces of plastic, smaller than 2.5 centimeters, making up 72% of our total. Now jumping across to the other side of the island, Te Amo Beach, that is a recreational beach. So what we have on our eastern coast is all drift plastic. That's our windward side. Te Amo Beach, we're not getting anything drifting ashore. This is all on us. This is all recreational use. So what we're seeing, we're collecting 3,400 items per survey. The number one thing is cigarette butts, making up 61% of our total. And then the yellow is metal, and I can tell you that's almost all metal beer bottle caps. And you can even see that big spike occurring. That was during COVID when all the bars and restaurants were closed. We didn't have a complete lockdown, so everybody was going to the beach to eat, drink, hang out. And so you can kind of see that we're trending back downward. So hopefully that beach will calm down a little bit. Our program, we really work towards local impact. So we use our data for awareness raising. We partner up with various organizations like A Plastic Free Bonaire and Nobo Recycling, which uses precious plastics machines to make useful products out of HDPE. We're included in the tourism studies curriculum. I do a beach cleanup with students using the Clean Swell app from Ocean Conservancy. We schedule with International Coastal Cleanup in September so that we can use our collected data for both. We also use the data for lobbying to the government of the Netherlands for the need to join the Land-Based Sources Protocol, because the Netherlands has yet to ratify it. Also urging more government work on waste management on the island, but everything with an eye towards the global treaty. We have our data shared with stakeholders via social media on our website and in a report to provide a baseline before and after our single-use plastics ban. Now regionally, because I mentioned the Cartagena region and how we need to harmonize our data collection. So there's been a lot of stakeholder work going on, and it resulted in 2 different reports that I worked on with a colleague to provide a roadmap for replicable means to collect high-quality harmonized litter data within our region. So we took a look at the best practices within the OSPAR region, as well as feedback from our stakeholders about what methodologies they were already using. Ocean Conservancy is right now the #1 source of data in our region, as well as their priorities and capacity needs. Essentially, what we recommended is that we could use the 2 complementary programs, so Ocean Conservancy for awareness raising and OSPAR on strategically selected sites in government-driven programs, but we need to have this set up in a government-supported regional network and have a data sharing platform. So for this, we desperately need capacity development because we have a lot of small island developing states within our region. But yes, we've answered the question. OSPAR can be used to harmonize data collection within our region in a manner that is consistent and harmonized with our neighbors in the OSPAR region across the Atlantic, and then we can use that data to work on marine litter solutions that we so urgently need. So thank you very much to all the people for making this happen, and please feel free to reach out to me.
Thanks, Carlota, sorry. And the last one is Zhao, in technological solution towards the guidance of micro-later monitoring.
I'm going to wait for the presentation. My name is Carlota, and I work for Ocean Mission. No, this is not mine. Let's see. Well, I work for Ocean Mission, which is an NGO that is in Húsavík in Iceland, and I'm going to present our work that we've been doing since 2019. So yeah, I'm going to wait to have the presentation. It's still not there. Okay, there we go. The title is Combining Citizen Science with Micro and Macroplastic Research in Iceland. So Ocean Mission is an NGO that was created in 2019, and it was created in Húsavík. It's a small town in the north of Iceland, and it was created because of the deep need for ocean conservation, not only in Húsavík, but in the whole island. Húsavík is a very small town that is very famous in Iceland because it's one of the places where you can easily see whales, especially humpback whales. So there is a lot of people, researchers and tourists, that they come to the bay that is called Skjærfandi Bay to see marine wildlife. So marine wildlife, it's seen from whale watching boats. So there is a very high pressure on the bay from the field seasons, which is from May to September, because as you may imagine, the weather conditions in Iceland is pretty hard. So the best season to go out at sea is from May to September. Our main goal is to inspire people to take action for ocean conservation, and for that we like to involve the local and international community, which is a lot there, and doing that combining education and science, using citizen science and volunteers for that. Since the creation of the NGO, we have a partnership with North Sailing, which is one of the 2 companies for whale watching in Húsavík. And thanks to that collaboration, we can use their boats. So we have 2 different projects with North Sailing. So then this is one of the ways to emphasize the responsibility that the whale watching companies should have with nature there. Once a week, we have one tour that is called Whales, Sails and Science, that we use one of the whale watching trips. So tourists are there, and then we take microplastic samples from that boat using our manta troll that I will explain later. And then we have citizen science sailing expeditions that we do 2 times per year, normally May, June, September, depending on the weather. So then people come on board, and then we take data on macro and microplastic. Thanks to that collaboration with North Sailing, we can explore remote areas of the coastline of Iceland. So then we gather very important data that can be used for policymakers, because at the moment, less than 1% of the ocean in Iceland is protected, and I don't know if you know, but whales are still hunted there. So it's very critical to keep on the conservation there and raise awareness in that topic. Actually, hopefully these things will change in the next years, and more ocean is going to be protected and whales are not going to be hunted anymore. Actually, in the last months, we got a very good news that the area that you can see in the circle, which belongs like Húsavík Bay there, the fjord on the left-hand side, which is called Eyjafjörður, and a little island on the north, which is called Grímsey. We call this area as a hope spot, and it has been recognized as that by Mission Blue in January. So it's very recently, and this is not a legal MPA, as we are probably familiar with, but it's recognition of an scientifically identified data that we need to take consideration because of the health of the oceans there. So hopefully we will bring attention into that area in the next years. So then coming to the research that we do, we have micro and mesoplastic research that we do from boats, as I said, from whale watching boats once a week, or from our expedition, sailing expeditions 2 times per year. Then we have the macroplastic research that we do following the OSPAR guidelines, and for that we do like beach cleanups, as we know. So for the meso and microplastic research, we take the lady manta troll, which is a do-it-yourself version of the manta troll, and it's lighter and cheaper. We did it ourselves. We take samples in a zigzag transect, which are 3 zigzag. Each of it is 30 minutes, and then you have to go in a sailing speed that is less than 3 knots. Every zigzag, after 30 minutes, we take the manta troll on deck, and then we analyze the data, first rinsing with fresh water, with visual confirmation to count and size what we see using the stereoscope on board. And then we store the samples in ethanol. For the macroplastic surveys, in Iceland, every piece of land is private. So first we have to find the survey site, which is like first that can be reached by car. We use a 4x4 because getting to the beach is quite tricky there. And then we have to ask for permission for owners so we can go there. Normally we get the permission, but I find like some cases that we cannot go to some beaches because the owners doesn't want to. So then once we have the beaches located, we find a group and then we do our OSPARM research with 100 meters. We save the GPS location and then we keep on cleaning the beach. Because of weather conditions, normally in Iceland we cannot do the OSPAR guidelines just there, so then we keep the trash in bags, in different bags, and then we check what we got, but indoors normally. So yeah, for that we always wait, even though like OSPAR doesn't goes with waiting, but we wait the trash and do the identification following the categories. Afterwards, then we take all the trash to the recycling center, which is located in Húsavík, even though recycling in Iceland is still not a big thing, and most of the trash is being buried or burnt, or like exported. We export a lot of trash as well. So here you can see the results that we've been taking from 2019 regarding micro and macroplastic. You can see that the north area, where it's the letter A, which is the hope spot, is where we have most of our efforts, and includes Grimsey, this little island that is in the Arctic Circle. This is where we have our base, so this is where we do most of the cleanups and microplastic research. You can see that a little bit on the east side, there is a peninsula that is called Langanes, that it has more than 8 tons of trash collected only in 2 years, as we start a collaboration with the municipality there. And like there are kilometers of coastline that is completely full of abandoned trash for years, and there is no efforts in the area, so we go once a year in summertime and we clean there, and yeah, this can be forever done. Okay, a little bit more in detail for the results of microplastic. Fishing lines are the most predominant type of microplastic, along with fragments, and boat paint is a thing that we find in the manta trolls always. So this possible boat paint has to go through analysis or spectrophotometry to check if it belongs to our boat from where we are taking the samples, and some of these results are already shown in this paper that has been recently published. Okay, the results of macroplastic surveys, as you can see, the efforts have increased a lot, and in the last year, thanks to some fundings that we got from the Icelandic government, then we can do way more cleanups. And as I said before, like we are doing 2-3 cleanups per week, and from 2019, 90% of all items collected are plastic. Most of them are fragments, but fishery-related debris is the largest single category only by volume. This here, you can see the top 10 items collected. That is probably a common thing everywhere, but in Iceland, a thing that I find interesting is like we have a lot of shotgun cartridges, which is the top 5. Seabirds and birds hunting is a big thing in Iceland, and there are a lot of abandoned cartridges on the beach that we find, so we hopefully want to find a solution for that soon. And just to end up, 4 different things is like regarding our results of microplastic, we found that there is an heterogeneous distribution on these particles, which are part of the dynamic of this subarctic marine environment. There is a predominance of fishing gear like everywhere, so we really need to tackle this problem. Whales are eating plastic, and we have one of our students that is going to publish her master thesis soon, as like there is a feeding ground in Húsavík. Our results, they all contained plastic. And we proved with all this data that we've been taking and we are keeping on taking, that citizen science is a very powerful tool, not only to involve people in ocean conservation, but also to gather data that can be scientifically shared somehow, like here. So that's everything. Thank you very much.
Thank us, Dota. I'm sorry because of the mistake. Johan, I presented before.
So I usually speak a lot, so I'm going to ask him. You can kick me if I'm going over the time now. I'll try to keep track on time. So my name is João. I'm going to show a couple of the things we are working on in terms of research to try and enhance and improve monitoring based on technology. So it's interesting to see that from Iceland to the tropics, we're pretty much facing the same problem with litter. And we try we are still at the stage, unfortunately, that in many places we are still trying to diagnose the problem. So how much litter do we have? Where is it coming from? And for that, it requires a lot of effort that mostly goes into people going to the beach, collecting litter, and then a lot of work also to try to separate it and try to analyze it statistically to try and figure out what's going on. And for that, we have a lot of work to put on, but you've also seen that a lot of this is in specific locations that not necessarily are illustrative of everything that is going on, both on floating litter, seafloor litter, and beach litter. And because I'm a geek with tech, I started quite some time ago dealing with trying to see how we could bring technology in and see if we can assist people that are doing monitoring. So as we are all aware, so this is a conference that anyone that is here is well aware of the problem. Plastics and other litter sources are becoming a global problem that it's harder and harder to ignore. There's a growing concern, and so all of us come to a point where we need to better understand what's going on. As we were mentioning, these are the three major questions that we face. So where is it coming from? So there's litter on the beach, there's litter on the seafloors, inside animals. Where does it come from, and why is that relevant? So if we want to stop litter coming into the marine system, we need to determine where it's coming from to try and act. What kind? Similarly, so if it's fishing, we have to act regulations on fishing. If it's plastic cups or straws on other locations, and then which impacts does it have on the environment? Obviously, as a marine ecology, at some point in my career, and I have to admit that early in my career, I didn't want to work with marine litter at all. But it comes to a point that we have to ask, how can I help? So what can I do to try and improve, and that's what brought me and a lot of my colleagues in Mare Madeira to start working. So over the last few years, Mare Madeira, which is a research institution within Arditi, that was already mentioned here, the Agency for Innovation and Technology and Research in Madeira, we published several different papers on different parts of marine litter, ranging from the COVID impact on marine litter to the specific effects. There's a plastic crust, which was a new discovery on a new kind of plastic pollution, etc. One relevant paper that we were involved was a kind of a review of what innovative solutions do we have to tackle marine litter on all the environments, which different types of litter, so macro and microplastic, but also on different things. So to reduce litter coming in, to improve monitoring, improve sampling, and then eventually collect. While we were doing this, we realized that there's actually not a lot going on. And so we thought that we could maybe help. Within Mare and within Clean Atlantic Project and Porto Santo Lixo, which is a EEA project, we brought in a colleague that is a computer scientist, so he has nothing to do with marine ecology or environment, but he's passionate of ocean life, and he started diving. He's a very peculiar person. And Marco, the challenge was, okay, can you do an app that will help us sourcing data from citizen science? So it has to be something simple, because people are not going to classify 150 systems on a tablet, but that we can leverage. And the advantage is, one, with a picture, we can also curate. We can go back and see what is there and try to figure it out which kind. Second, it's geotagged. So it can, in a very effective way, we can see how much items and where. You can download the app. It's available for Android. It's free, so I'm not making any money. The app has the ability to also work with whale watching companies and marine operators, and it has a backend, so there's a website where you can log in if you're a user, and you can see which items you have tagged, and it automatically puts out a brief report on which kind of litter, so the major categories used on OSPAR, so it's just material type, and you can select a month and you will automatically see how many items from each type. Okay. The second part of this was on research. So being a geek, as I mentioned, when drones started showing up, I was excited to use them for habitat mapping in coral reefs, so I was working in the Pacific. When I moved to Madeira, I said, well, maybe we can also use it for litter mapping. And so we started off with beach litter and using the 100 meters. We realized very briefly that it's not worthwhile to replace a 100-meter transect with a drone because it doesn't give you as much information and it still needs a lot of processing. Maybe it's not 5 people in the beach, it's 1 pilot, but then the amount of time needed to do the mosaic, count the litter, or train machine learning is very extensive. And so we opted to use drones for, first, can we do it from vessels and for floating litter? And we tried different things. That drone lands on water. It's actually not the best option because it's hard, it's big to manage. So that was one of the first ones. We have now moved for other sorts of drones. And what we did is that we used floating litter sampling, which was basically using manta trolls with a bigger mesh. And we tried to see if locations with hotspots for litter were also hotspots for macro litter detected by remote sensing. I'm going to move forward. On the beaches, what we realized was that even though the 100 meters was not ideal, what we could do is in locations where we do have information of 100 meters, we have which type of litter. But then we can expand our sampling ground by increasing the number of flights to locations that we typically don't do with the sampling on site to try just to detect how many items. And so with this, we've been able to, by normalizing data, to combine our data with data, for example, from what is collected by DGRM, by DRAC now, with the team that Nicola was presenting. On top of that, we also do our own monitoring, like I think that Sonia, and we also include some of the data that we use from the beach, and we can normalize. And so we can now assess with drones, expand our network of sampling and see how much of the other area of the coastline is polluted. The other part was on floating litter. On this, we just published a paper recently where we test both manual detection and machine learning. Some machine learning is useful specifically if you have a lot of images. And we have been able to successfully get some successful models in automatically recognizing litter. We are also working on integrating multispectral data, which allows you to go into the infrared and near infrared to make this obvious. So the middle image is dummy items. Actually, it's bread on the water to see if we can detect it more, so if the algorithm can detect it faster. And we have been exploring that with some success. And most recently, we have also started doing the use of technology for seafloor litter. I don't have a lot of time, so the video is nice, but I'm going to move. We basically use the ROVs. The ROVs and IOVs allows us to use different types of cameras. We then use collaborative tools that allows us to simultaneously annotate with different people across the world. And we detect on that circle there's actually a fishing line entangled in some whip coral. This is at around 110 meters. So this is something that we can do that it was previously very hard to do except with trawl. In Madeira, in many locations in the world, there's no trawling allowed. And using trawling specifically for sampling is still destructive. So one of the options is the video analysis, and you can then look into the video and look into the different types. We can also use other platforms that are more interesting. I had the privilege of diving on a submarine, but obviously it's more expensive. It does have an advantage that ROVs are coming up to, which is the being able to have a good positioning systems for tracking, which allows us to not just have a perception of an area, but also have a track where you have actually the density of items that you can get, and the type of interactions per habitat. So we can see how you can have a lot of pollution, but maybe in some locations you have less pollution, but it has a bigger impact because the habitat is more vulnerable. So that's very important for us to determine. Most recently, the video is not playing, but most recently we've been using multi-camera systems. This is from a drone. So we've actually found this. This was on a survey, we found the wreck. And you can actually see the wreck and you can see items around it. And we are now integrating machine learning, also another paper that was published, to automatically detect this from images. The low-cost solution in the end will be this kind of apparatus. It's actually from the Azores. I think there's someone here that has already worked with this. We want to build up on this, and we are collaborating with them. This will allow us to tow the camera. It has less accuracy, but it coverages, instead of 300 meters to 500 meters, it covers like 10 kilometers. And I think that this is it. For the future, these are the new challenges. And at the end, I think that everyone in the room can relate to this, is we all have to ask, how can I take my knowledge and what I do to contribute and help sorting out the situation? Thank you. Obviously, I'm not alone. These are some of the people that I work most closely, and those are some of the projects that have been involved in the development of these technologies. Thank you.
Thank you very much, all of you. And now, if you want to make any question to this team, it could be a good idea to start with you. If no, I can begin for us. Okay, so I begin. Okay, I have a question for all of you. Okay, it's not independent. I was hearing about survey with monitoring and more technical survey, voluntary survey, and no innovating survey. What do you think is the pros and cons of every one of them?
Can you repeat the last part?
Okay, the pros and cons of every one of them, voluntary, technical, and innovation ones. Please, a microphone.
Okay. So I know it's for all of us, but as I was the last, now I'm the first. So I would say that standard methods are key for good science, and we all acknowledge that. The problem is that if we want to have timelines and analysis over time or over space, we often tend, if we get stuck to standard methods, to not evolve, right? So there's innovation, and we need to keep up with innovation that will allow us to either improve the quality of the data or enhance the scope, both temporal or geographic. For example, the drones. The drones, we still can't go over and classify the 150 categories, but we can cover 4 kilometers in a fraction of the time. Mm-hmm. And with machine learning, or even with manual annotation, so if I make the mosaic, it's automatic, and then I put someone going there to the image and inspecting and tagging objects, it takes, for a 4 kilometers transect, it takes about 1 hour. If you were to do 4 kilometers of OSPAR methods or MSFT or any other, it's impossible. It will take weeks. And so that's the advantage. And the important thing is we need to find a way to correlate data that it's collected with standard methods that characterize, and how we connect it by modeling, statistics, etc., harmonization, data harmonization, with the data that is collected elsewhere. And so for us, in our team at least, that has been the challenge and the motivation to improve on technology. We want to sample more habitats with bigger frequency, so more often, and have a better extent of of the status, of the pollution status at this stage. So that's the caveat for us. I don't know if...
Okay, for my case, I will talk about the water because this is where I'm most comfortable and used to work. When people work on microplastic and marilitter on the surface, the easiest way is to work on the surface. I think all of us, we are using the manta to work to survey the surface. The problem is the water is not surface, it's also depth. And it doesn't mean that when you are sampling the surface that your water is clean. That means that below is the case. As we showed, we find sometimes more plastic in the bottom. This is the problem is if you want to go to sample deep, this is where technical issue starts. And demands big ship and a lot of logistic. And this is where maybe the new technology can help. It can be cheaper and easier to go deep. So basically, I think all the future technology will have to manage the different environment. If you're working on the beach, it's quite easy. If you want to go to the water, is there a lot of technical issue to need to take into account?
Javier, no.
One thing that I think you asked regarding like how pros and cons for volunteering, for
Yes.
example, as we do a lot of volunteers, even though we always have a coordinator with them, I think I'm talking like by my experience in Iceland, but I think it's very important to involve people in that because it's a common problem and it's not my problem, it's not everybody's problem, but it's all of us problem, and especially in Iceland there is a very wrong idea that Iceland is clean, and it's not, because I don't know why we think Iceland should be clean, but it's not at all, and probably because we don't visit beaches as often as we do here in Tenerife, because we cannot enjoy the weather or we cannot enjoy the beach. Then people, I'm talking about tourists or I'm talking about researchers, because there are lots of researchers or people that go there for working in the summer season. They would, like my experience from the people that come with me for cleaning the beach, like they will never expect what we find. And it's very important that people come and see, like, Iceland is full of, Iceland, I say Iceland, but everywhere is full of trash, and it's not a problem that it can be isolated in the Mediterranean or in the Caribbean or like in the Arctic area. It's full of trash and we have to tackle that problem.
Okay.
So, yeah.
Anyone else? Javier?
Well, pros and cons. Obviously, when you involve citizen science, I mean, you can reach places where you cannot normally reach, and you involve people in what you're doing, and people are more conscious about what the real problem is. No? So that's probably a positive thing about it. The negative thing is probably that what Joao was saying before. We don't have standard protocols, and many people are doing different things. Of course they are important, of course they are useful, they provide important data, but the thing is that some people are doing it in a different way. People are doing it in a different way, and we are not able to put them together. So it would be great if we find or manage to do it in an orderly way or in a common way, so that all of us can benefit, or the society in general can benefit from all those data. So that's probably the negative thing about it, that we have not yet reached, a common protocol. Although we try to do it, we try to follow certain guidelines in that sense. But I think many people are doing many things in a similar way, but not exactly the same one. So probably that is the main con in this case.
Okay. One of you, or there are other questions? No questions? Okay, I can continue. Don't worry. Okay, do you talk, Javier, about the quality of the data depending on the sources of the information? And in other way, I don't remember who, wait a minute, because data processing with Sonia. Okay, you talk about the issues with data processing and how do you process the data. Okay, what is the way you merge the data? Okay, you have different sources of data, you merge the data, and what is the issue that the data processing could create on the analysis you make the data? Oh, sorry.
How do you use, which different ways do you use to handle data differently from different sources? Do you have an issue or not?
Not really, because not really how to process the data, because usually the protocol we really think since the beginning. So, and we kind of know, okay, where we start and you know how we will finish. So there is no like surprise when we process all this data.
Okay, and when you process this data, you could get any sesgo, I don't know sesgo in English, some bias in the data, or is usual the protocol avoid this bias?
No, usually the protocol is standardized, for example, and when we, for example, we have samples, and I, for example, analyze samples, I tend to want to know where the samples come, to not be potentially biased. But usually the protocol is standardized to avoid any potential way to bias, making more plastic here because we sampled more here. Usually it's really strict protocol to avoid any potential influence from our side or other.
Just a point. We're talking about environmental data. We're talking about data. I mean, we go to the environment, we analyze different type of things, talking about marine litter, plastic, but also contaminants. When we talk about environmental pollution, like in this case, data is extremely variable. I mean, even in a beach, you may have extremely high variability in those data. You may have we do have it. Yeah, even in a beach, there is a certain part of the beach where you have maybe you have a higher accumulation zone than in the other. So the data is extremely variable. We do not have even seasonal variations. At least when I talk about microplastics, we have studied this issue during many years, and you do not have a seasonal variable. You do not have a tendency. So data are very random, and sometimes extremely difficult even to interpret certain results. Like in our case, if I mean, as I told you, you may have a beach that has high concentration of microplastic during a certain part of the year, and then in the following months or the next month, it's not in that way, because we depend on environmental conditions, we depend on currents, when they are not the same, and they are not repeating in the same way. So we have extremely high amount of data that sometimes is very difficult to deal with. And when you talk about the environment, you may have extremely high variability.
Okay, yes.
So the thing with data quality, I think, is one of the biggest challenges in monitoring and science in the marine environment. And one of the reasons is this: so the variability and the factors that affect whatever we are measuring are huge. So there's multiple ways of handling it, and most of the scientists have pushed, and we continue to do so, and rightfully so, for standard methods. The standardization is a way of reducing bias by the method itself, which is fine. The problem is, and we've come to realize, being it because of seasonal variation, daily variation, weather forecast, it doesn't matter. Being because whatever it is, we still struggle to find patterns. We still struggle to compare data directly, right? So I go, for example, we were talking before, for example, is the data of the FOMAR protocol on plastics the same as if we use the Corey shearwater? Probably not, but that's what we have. If I don't have a FOMAR, I still need to deal with it, and so we need to adapt. And the thing is, and I think, and if you realize, if you look back over the last couple of years, we stopped pushing and talking about standardization of methods, and we started talking about data harmonization and harmonization. And the difference is that harmonization goes under the principle that there's no correct method and wrong methods. There's multiple methods which have different advantages and disadvantages, and we have to find a way of combining them, and to be able to compare the FOMAR with the Corey shearwater, or or make a leverage, okay, I use OSPAR or MSFT classification, but I can still use drone data or citizen science or the app that I showed to still get other layers of information. It won't give me the detailed information on the type of litter, but it will give you so many more points of data that I can see in terms of spatial pattern or temporal pattern, which 4 times a year in a few beaches doesn't really have a meaning unless we're looking into tens of years, right? So we can see if over 30 years there was an increase or decrease on the type, but if we want to look seasonality, it's not going to happen. It's either modeling or getting additional layers of data. So I think that the way to go is not about pros and cons, or it's how can we link data? We can get advantage of all these data sources and we link it. And I do think that, and I'm not a big fan of machine learning, but I do think that machine learning is now at that cusp of allowing us to find these patterns and connections.
Good.
And if I can just say, I really enjoy how we all seem to be very much on the same page of, you know, what we recommended in our region is using a hybrid approach, using some basic citizen science that also has some strategically selected, more long-term, routine, high-resolution data collection, and that we can do different things with it. We can raise awareness, we can see our standing crop on whatever beach from clean swell or ICC, but then we can see our trends over time, we can see our flux accumulation by using a different scheduled, more structured approach. So it really warms my heart that everybody is really, you know, heading in the same direction on this.
Okay, I agree with you because I'm a lover of machine learning and data science, so I love this way. And talking about the huge data that you have, you say, Javier, we have a lot of data, we have a cube of data, but I don't really believe in the random of the data. I believe more perhaps in we don't know every impact that other data have in our information. And it's the thing I believe the machine learning, artificial intelligence is helping us to grow, to introduce in this way, and to understand not in a univariable or bivariable analysis, in a multivariable analysis that our minds can manage. But it's my opinion, and we can talk a coffee later. I love this way. Okay, but thinking about the data, sorry. I was hearing, I love too about the procedure or the standard to recover data. And Nicola, you told before that you change from OSPAR and you manage nowadays OSPAR methodology to measure the monitoring. Why do you do this, and what is the impact is this having your monitoring? Because when you change the methodology, you change the data or not?
I'm not sure if I understand.
Okay, you change the monitoring system from your system to OSPAR, no?
We tend?
We move to OSPAR.
Okay. You are asking why
Why did you change why did you move to OSPAR, or what was the impact in your data?
Okay, so we think that with the data that we collect and the amount of data and the consistency of the data that we collect are even though we are not part of the OSPAR, we are part of the expert group that Lex talked in morning, the beach litter expert group, and being part of that group is important for us and to develop and to have more accurate data and methodology. So we think that our data will benefit too for the OSPAR, and we benefit from being part of this group and also being in contact with those groups to improve our work. Okay. So I think it's a two-way benefit thing.
More about OSPAR? Perhaps, Caroline, you talked about you change the protocol for measure on 100 meters to 50 meters, and it could be an impact in your data, in the measure or the graphs.
Well, we took a look at that. That's a really good question. When we were first thinking, oh, we're going to have to cut this in half, it just takes too long to collect that. But one of the things that we did is we were looking at the UNEP 2009 standards for beach litter monitoring. And one of the parts that they mentioned was that really the reason why you want to have a certain sampling length is not only the amount that you're collecting, but the variety, so that you're getting a good sampling.
Okay.
And so they took a look at how many different item types you find in a set area, and had a recommendation. I can't remember exactly because this was a while ago, but you wanted to have at least like 25 different types of items in your sampling site or something. I'd have to look it up. But we had plenty. So when in our first clearances and our first samples, I looked at, we were finding quite a large variety of items. So we were reasonably certain that we were able to say, yes, we can do this. And also on different, and to replicate it on other Caribbean beaches, we don't have that kind of long stretch of beaches. We have a lot of little coves and little bays. And so, in order to put this in place, we needed to be able to cut it in half. And in fact, some of the OSPAR sampling sites aren't exactly 100 meters, but they normalize it when they're running it through the litter analysis software to look at the data. So there were a few factors that we put into place. But yeah, it's not entirely perfect, I agree, but it was the best we could do.
No, I agree, because I don't think that the protocol have to be fixed, and sometimes you need to adapt it, okay? But it really that perhaps they have an impact, or sometimes they have an impact about when we are talking before about voluntaries and more methodologies, more serious methodologies. When you compare with the statistical test, it's demonstrated that it's working. Okay, so it's no issue. It's a way to improve and to enrich the data, as you say before, with all this technique, all these new ways to survey, to monitoring, you can enrich it. So I think that you need to adapt it. I agree with you. No, it's not for
but
the other side.
With working with the data, the thing that I realized is that you really want to start with what you're going to work with. And we added in 2021 the joint list. So we took the OSPAR list that is about 112 different litter items and putting on the joint list. And OSPAR changed some of the litter items. So it used to be plastic and polystyrene pieces were one group. And quite recently, they split it into two. And so when you're analyzing it, you have to aggregate it back to the lower resolution one. And then when we added the joint list, we added litter items. So now my data set, I have to sit and aggregate items back together if I want to show the full trend over time. So that what I'm recommending in the rest of our region is that people start with the higher resolution one so that the data set is easier to work with.
Yes, it's easier to aggregate than disaggregate. I agree.
I know. But yeah, adding masks and things. And now I've added wooden forks now that we have a single-use plastic ban in place. Things like that. There's always going to be emerging items. But.
Please. Could you face a microphone, please?
Thank you. Gracias. So, well, I have a question, and this question is a little bit, I'm very surprised and happy that everybody is involved and really cooperating for the environment, and it's so incredible how Madeira is close involved. And my point is probably, we geographically, I was talking about this with the professor who does the introduction in the conference, and my point is we are geographically more close to Africa than close to Spain. I mean, we are in the Canary Islands, and our coasts are very close, Lanzarote, Fuerteventura, to Ayoun, to Mauritania, to Senegal, to West Africa. I've been a sailor for many years. I've been 30 years in the merchant marine. And since I retired, I am involved in this project.
Could you advance because we don't have more time?
Sorry, yeah, I'm going to be quick. Anybody's been thinking what happened with the coast of West Africa, because we can find the garbage litter in 2,000 meters deep here in Lagobera and Tenerife or whatever, because the sea is very deep. But it's like it doesn't exist, the coast of Africa. We are very close. Everything comes from there. The exposition we have outside here, there are pieces of buoy, nets, and this cage, I don't know in English the name, nastas in Spanish, they come from Mauritania. I can recognize, I know they come from there, but okay, what we're going to do? That's my question. Thank you.
Javier?
You mean, what are we going to do, or why do we have that? Well, I'm not a physical oceanographer, but I know well that in the west coast of the African continents is very frequent, and down the Canary Islands is very frequent to find this vortex, this so-called mesoscaled movements that somehow bring part of the litter to the south of the Canary Islands. I know there are some people nowadays modeling sea surface, and they are observing somehow that part of that litter is in fact coming from that specific place. Well, this is something they have not published yet. They are studying that. In particular, they are finding many fishing nets that are entangling turtles and so on. And it seems that in that part specific, they have a higher amount of turtle entanglement and so on, because they are coming, they say, from the African coast. But other modelings are also telling us that they are coming from the North Atlantic. But we have, let's say, these two possible sources in the islands that we still have to look in deep in the following years.
Hi. It's funny that it is true. It comes from Africa and from African coasts, but I don't think it's all of it produced in Africa. Right? So maybe we are having this conversation here and they are having a conversation, well, what are we going to do about all the litter that the Europeans and Americans are bringing to our coast, right? So the one thing, and I'm saying this because I lived in Cape Verde for a while, and I can say that one of the first times I did a beach cleanup, we were scheduled to be, I don't know, it's about 1 kilometer of beach. We had 200 people. We managed to go 1/3 of the way. And this was all foams and pieces of the same thing. It comes from this current that goes down in the Canary Current, goes down to more or less Mauritania, Senegal, and then it crosses away to the middle of the Atlantic, and so it pushes everything in Sile Island. So in the easternmost islands, the east coast is full of litter. And if you manage to clean it in 1 month, it will be full again. And so, yes, there is an issue, and now the question, I'll go back to you with a question, which is who has the skill or the authority, or who can handle that, right? So, and I would say that the international cooperation politically has to be key. And the best we can do as scientists, NGOs, and etc., is again, what can I do to help? So I'm not going to make the matter worse. I'll try to make it to facilitate the way of diagnosing the problem, of mitigating the problem, etc. But in the end, unless we are making like this kind of Chinese wall around us, we're going to be affected by other people's litter. In Madeira, we have most of it comes from the coast of the U.S., from Maine.
Yeah, exactly. Much of what we're finding on our east coastline, we can see that it's coming from Venezuela and South America, and So I think this further highlights the transboundary nature of marine litter and reinforces the need for a global agreement on plastic pollution. We have to solve this problem together. But then if we look, even if I could prove that everything that was washing ashore in Bonaire was coming from Venezuela, they have a lot of other economic issues going on there. How are we're going to say, oh yeah, can you guys please improve your waste management? And well, how about we look at it as a social justice issue? We find a lot of bottles washing ashore because many people in the world still don't have clean drinking water. So I think that we need to really look at the big picture and how if we improve the quality of life for people globally, we can also help ourselves solve this transboundary problem. But that conversation gets really complicated really, really quickly.
Okay, we can continue later. So we finish or no? If you have any question more or in the public, okay, we'll do and you first.
And now everyone is not shy anymore.
Hi, this is Mike from the Angel Shark Project. Congrats on all your talks. So my question is that human and economic resources are usually the limiting factor for monitoring marine litter and any type of research projects. So I was wondering, have you managed, or do you think it would be a possibility to combine forces with other monitoring programs that, for example, are monitoring megafauna, sediment, plankton? Would you get the correct data? Would that be an opportunity to gather data on marine litter? Do you think it would be a possibility?
Sorry, you can also answer this one. Yeah, I would say that as I introduced earlier, so we are ecologists. We are not. We come from a background studying bugs and animals and biology. But the fact is that that's how we came into this, right? So we started we were looking into community structure, and we realized that some locations where a few years ago we didn't have any fragments and plastics now have a lot. As Sonia was mentioning, she started finding a lot of microplastics in their samples. So definitely there's room for combined approaches. I would say that on top of my head, things like, for example, most countries have a fish stock management program, like a monitoring program, that they could collect fishes from the fishermen to sample size, structure, and assess stocks. At the very least, have a joint program with them to see the impact of microplastics and ingestion. Makes sense in my head. I would say that on you mentioned marine mammals. I don't see. I would say that like the whale watching companies that do, we also do it with the app or with mentor trolls. But I'm not sure that there's, and scientifically there's people that do, we have a colleague that did mentor trolls on locations where they spotted dolphins and where they didn't, to try and see if there's overlap. But that will always be kind of scientific, right? So it's research purposed. The question that I think that we are now on the verge is we need to stop just doing research and having NGOs and researchers contributing to data that is monitoring and putting that responsibility on the political side of it, right? So the countries have a responsibility in the same way that they monitor population trends, disease trends, etc. They have a responsibility to manage their waste management systems and their contamination levels. And for that, I think that it shouldn't be piggybacking on anything else. So we should have a strict program like Madeira, for example. I'm not from the government, I'm not from the politician, but they did this right, in my opinion, which is they took the responsibility of saying, okay, we can have the researchers, we have contributions, but we take in our own hands making a program, and I think that's the way to go.
Okay.
I don't know, you may have a different opinion because it's a...
We are going to talk about impact and solution in the next session, so perhaps it's better to manage this one in the next one. Okay, sorry. because the time is not enough for all the thing, and it's better not repeat. And I think you have other question.
Yeah, I have a very quick question about identification of plastic. You talk a bit that you try to identify the plastics that you find, and my question is, do you have like more or less a percentage of the plastic that remains unidentified? And the reason is that it doesn't have any characteristics at all that you can use to identify it, or it's because you cannot reach the people that may be able to identify them. For example, if you find plastic from South Korea, you are not able to reach these people. Or yeah, I'm curious to know what is the reason, if you know, of why it remains unidentified and which percentage it remains unidentified.
Well, much of what we're finding is just really fragmented. So you're just finding these unidentifiable pieces that you can tell it's hard plastic or that it's foam, that it's styrofoam. But beyond that, I mean, we have a lot of fun with our citizen scientists going, oh, we've got another unidentified beach object. What could it be? But, you know, if we're not definitely sure what it is, we just put it in the unidentified category just by size. And what that does is it further reinforces, you know, our total count that we know that the oceans are full of plastic and that plastic is breaking into smaller and smaller pieces. But within the OSPAR monitoring protocol, we don't really have that brand identification that I know there are some good protocols out there. We haven't added it on, but it could be another level, particularly if we're moving more towards extended producer responsibility. So I think that in the future, you know, there's so many, again, as we're all reinforcing, there's lots of different layers that we can be adding on microplastics as well as brand identification and other things that can help us to better work on the solutions.
I think I can add a different light in this sense. When the plastics are really fragmented into very little pieces, you cannot really say this belongs from somewhere. But you can use different techniques, different spectroscopic techniques like infrared spectroscopy or Raman spectroscopy, where you can clearly identify the polymer. But you can identify only the type of polymer that it is. You can say this is polyethylene, this is polypropylene, this is PVC. You know, you can identify it, but not the origin, okay? So you can do that. Normally, the plastic in the environment weathers. It gets old, like the people, you know. So this composition of the surface changes, and as a result of that change, sometimes we are not able to fully say this is polyethylene or polypropylene. So we have difficulties in the matching, because what we do is we analyze the plastic, and then we have what we call spectral libraries, and we see the matching, the percentage of matching between your spectra and the spectra of the library. When it is around above 70%, you can be sure that that is polyethylene and polypropylene. And as a result of this weathering, we have some percentage of plastics that we do not identify the composition. Normally, we're talking about between, let's say, 0 and 30% of the plastic. It gets old enough, very, very old, and we are not able to identify it. And the problem gets even worse when we're talking about extremely, extremely tiny, tiny pieces of plastic. For example, we're talking about microfibers that come from our clothes. Imagine that microfiber in the environment getting old, and you need a signal. Your instrument needs an enough signal for that, and sometimes you do not find it. So the problem gets really, really worse when the size of the plastic gets even down. But we are able to do that. Of course, you need important instrumentation. We're talking about, if we're talking about plastics that you can see, maybe you can buy an instrument for 20,000 euros, but if you're talking about microfibers, you need an instrument between 100 and 200,000 to do that. So that is only practical for an environment from a research point of view, from universities or research institute, but not for this type of monitoring
the monitoring there of citizen science, but you can do that. We can do that for sure.
Okay, sorry, the last one. Yes.
Just to say that we also in Madeira Island, the items that I showed you that we can identify the origin, there are the less, they are the minor percentage of the items that we find. Most of the items that we find are not identifiable, nor the origin, nor the item itself. What we found most is fragments of plastic, of foam. That's the top 10 items that we find. I talked about the source identification because of this problem that we are all now facing, that is transboundary pollution. So we are now with the aim of studying this in particular, the source identification, in order to tackle this transboundary pollution. So that's why I talked about.
Okay, thank you for the collaboration. We don't have sorry, we don't. Okay. Okay. No nos dejan comer.
It's about, this has worked? Yeah. It's about the identification of items. Of course, within OSPAR, we always counted the very small pieces smaller than 2.5 centimeters. But now we are developing the threshold values, and we realize that these very small items doesn't tell us much and what type of measures you can take. So the threshold value, and we're following the European threshold value there, which is 20 items for 100-meter beach. There we exclude these small items. So also the data that you saw in my presentation this morning, the 200 to 350, the small items are excluded there. So only the items where we can say more or less what it is, where it's coming from. And in general, fisheries, they have bad luck because they are very easily recognized. But a lot of the other items, they can come from different sectors. So you have to approach all the sectors, or you should have a European directive that tells you no more plastic bags, or no more plastic bottles, or no more plastic cotton bud sticks, or whatever, because they are easy to identify. So it's good to count the small items, but if you really want to make measures, it's better to start with the identifiable items, because you can develop measures, and that's what we want. We want to have measures, because if not, we will clean up beaches when I'm dead and gone in a long time. So focus on the identifiable items. I think that's a very good start.
Okay. Anything else? We are starving yet, but the last one? We can one more? Last one. Yes, last one. No?
Well, let me see if you can understand me. I've been in some Congress for many years, and always we saw a lot of work and trying to identify technology, see the size of the items and of the small particles of plastic, and many efforts to bring data and to know more where it comes from and where it goes and how quantity they are in the world. But I think at this time we already know that there's many plastic on the sea, and we all know that it's very difficult to take it out. And I don't know, I don't understand very much, you know, the object or the goal of the data and all this kind of information, and why we don't focus more in how to make it disappear. But
because
I think that's the goal.
This is tomorrow.
This is tomorrow.
Sorry, but this is tomorrow. No,
okay.
No, today, tomorrow. Okay. We are starving yet. Sorry, we are starving yet. I have more questions too, but it's lunchtime. If you want, we can continue the conversation in the lunchtime. Okay, thank you. Thank you for your presentation. Thank you for your collaboration.